Welcome to the presentation of Peaceeee. Today we are talking about the semiconductors of this, an analysis of how semiconductors play a crucial role in modern living. Due to logistical problems, inflation, and the job market in recent months, the shortage of chips was sparked by the pandemic and many other factors. This project will investigate in how the semiconductors only contribute a small portion, but they provide trillions of dollars worth of production. We will divide the report into three main sessions. The first one is an overview about the semiconductor market. The second one is an insight into the chips industry. And the last one is government intervention. First of all, what are semiconductors? A semiconductor is a material that transfers electricity between conductors like metal and insulator or ceramics, allowing an electrical current to easily flow in one direction. There are several types of semiconductors, and we can find it in everything nowadays, like smartphone, car, camera, and even television. Now we are moving to the industry structure. The first tier supplier of aluminum, mineral, and metal for the process are part of the semiconductor supply chain, and are second tier suppliers of semiconductor machinery. First of all, we move to suppliers. We can see some leading suppliers based on 2018 market share data is Samsung Electronics, Intel, SK Hynix, Micron Technology, Broadcom Limited, Qualcomm, and Texas Instruments. Look, from the line charts, we can see there is an increase in firm concentration is evident from the drop in number equivalent, which move inversely to square market sense. Now, let's move into the vendors. We can see some top vendors based on 2019 market share data. Is Samsung Electronics, SK Hynix, Micron Technology, Broadcom, Qualcomm, and Texas Instruments.
The ability to accurately predict the future trends, however, is a tremendous competitive advantage that may provide a company prospects for long-term growth, allowing them to be even more optimistic with their development. The relationship between the business cycle and technical expandment is unclear for the semiconductor setup. Products are developed more quickly than the product cycle setup. Every year, 1 to 3 goods from each era that were developed over the duration of 5 to 7 years will be realized by a certain company. Until the competitors can make an absolute order to condemn, the advantage that were breakdown have offered seldom lasts for very long. Due to the short-term price that follows the introductions, businesses are encouraged to start investigating units head to expandment and gain a competitive advantage at this time. The development of the demand and effective product platform gets more cost-intensive and thus longer since the market now has to accept the wide range of highly specific and individual requests depending on the client. Similar to predicting ability, building a product platform involves some confidence along with a strategic approach. The length of time it takes to build the creation of new platforms also makes these predictions on trend trickier and more uncertain. A fabless manufacturer may play a gamble on the market feature that become practical 5 to 7 years later. The semiconductor supply chain entails a variety of phases and processes, all of which are required to make it functional and effective. As you can see on the left, the semiconductor supply chain starts with system companies able to invest IC design, IC manufacturing, IC assembly and test, and consumer and cycle back to system companies. For the supply chain management, the four principles are cost control and risk assessment of participation and continuous improvement. The COVID-19 pandemic and the trade war have impacted on a variety of worldwide sectors. However, still have super supply chain challenges as intensive as semiconductor companies, faced with a significant interruption in both supply and demand. Semiconductor business work compelled to move with unforeseen speed in order to manage their business and operation effectively. On recent list to the shortage of semiconductors in 2021 caused a reset of the global economy, considered to form a case the world's largest buyer of chips. Apple delayed the launch of the iPhone 12 by 2 months. Moreover, a typical representative of Vietnam in past is dealing with the situation leading to delay of the delivery of cars to the customer.
I'm going to talk about an insight into the semiconductor market. First, I'm going to talk about the value chain. The process of getting electronic product in front of the end user at an affordable price and in a timely manner has proven to be exceedingly difficult, since the semiconductor production has grown incredibly complex. A lot of businesses have struggled to get enough chip to match consumer demand for product. For example, the entire finished product manufacture may be delayed if a single chip is at risk. This figure shows the flow of the value chain of a semiconductor production. This image shows the design company of the chip, the manufacturing company of the chip, and the demand for different media of device that require the semiconductor chip. I'm going to talk about the supply and demand. So in short, the semiconductor shortage is the product of an explosion of demand in the face of consistent supply. A perfect storm of skyrocketing chip demand unexpectedly from the specific business like cell phone and PC during the COVID-19 epidemic. It triggered a shock to near-term supply chain, leading to an unprecedented global shortage. The entire global supply chain is still incredibly disturbed. Unfortunately, in the near future, there's no indication of rebound. Now I'm going to talk about the determinant of demand. The first determinant is the COVID-19. The COVID-19 pandemic has caused remote work or work from home to expand, leading this trend to the high demand for the large number of electronic devices. And then there's the explosion of the smart device. IoT, AI are already presenting around us, and there is Wi-Fi in the house. Robot cars are integrated with small features like face recognition, object detection, and so on to make convenient life. Therefore, they consume a lot of semiconductors. And here's the determinant of supply. First, we have the US-China trade war. Additional tariff was placed by the US and China on item import from other country, meaning buyer in the opposing country would need to pay higher import tax to bring their purchase into the country. The culmination of that is the imposition of sanctions on Chinese technology companies such as Huawei, ZTE, making these companies unable to access chip copyright, affecting these company operation. Companies like HiSilicon failed to reach an agreement on carrying chip production. Another determinant is the Russia-Ukraine war. The war between Ukraine and Russia had led to global shortage of semiconductor. For the production of semiconductor chip, Russia and Ukraine are important sources of neon, helium gas, and palladium. According to the official, the amount of helium gas from Russia accounts for about 1/3 of the global source, while 35% of the country palladium come from Russia. Over 90% of the US supply of semiconductor-grade neon originate from Ukraine. If the war lasts longer, it will continue to keep limiting the chip source for manufacturing facility. And there's also a special profession. It is a very difficult this industry to reach. R&D costs are high and the responsiveness of small and medium-sized companies is very low. For example, in the world, the number of companies manufacturing chip is only few companies, while the copyright manufacturers are less, such as ARM, Intel, or AMD. And then there's the elasticity of the market. By the spring of 2021, the effect of chip scarcity was evident to the automotive sector. The factory has been forced to reduce production or even shut down temporarily due to part disruption. With more government mandating electronic vehicles around the world, this limited supply of chip is being put under more pressure. Auto manufacturer and chip industry professional has already voiced fear that the project chip drought have stalled the release of these vehicles, particularly in the United States. Chip shortages are also raising the price of new car. The cost of new car on average increased to unprecedented high.
Let's get to part 4, production and cost. There's the fact that the major cost to generate chips is the physical, which primarily come from R&D and CapEx used to design the new architecture, development tools, and manufacturing methods. and build new fabs. Like for example, the Intel marked grand opening of the $3 billion factory expansion in Oregon. The the economies of scale. The enormous capital to start the semiconductor business create an incredibly high entry barrier, which inhibits entrepreneurs with venture capital backing from the development affordable products to take against a larger company. This would create the monopolies and thereby the semiconductor industry enjoying the concept on continuous economy of scale. The next part is sustainable development. The company should reduce waste, improve material source. Business needs to concentrate on finding ways to reduce stress on water resources, and the sector must be able to reduce its long-term transportation footprint and manage the usage of the dangerous chemical. Like for example, the Intel sustainability goal results. The next part is how firms are to pieces. The chip, foundry, and manufacturer have strategically of their investment in new fabs and factories to combat the consequences of chip shortage and a lack of capacity brought on by the rapid demand. However, there are far more fabless companies generate economic profit than the others in manufacturing-related business domains. These companies invest in continuous innovation for new applications, and they constantly expand their core intellectual property.
Okay, I'll continue the presentation. Let's move to the government intervention section. Why there is a need for government intervention is necessary and urgent, considering the following five cases studied below come from 5 representative countries. In Japan, Japan's new regulation on controlling export from Korea is having a ripple effect beyond the borders of the two neighboring countries on the global electronic manufacturing industry. So, the Korean chipmaker will have to stop production if it can't buy the necessary material from Japan. It will cause a serious disruption in the whole value chain of the chips. In the United States Senate voted to invest more than $50 billion to lessen reliance on manufacturers in Asia, due to the trade war between the United States and China, limiting export of United States equipment to Chinese memory chip makers. The new rule also restricts shipments to China of supercomputing chips used by nuclear weapons and other military development programs around the world. In Europe, United States and European sanctions against Russia still continue, and this can affect the process of producing semiconductors. So, the government have put a lot of reform to remedy the market failure to address the semiconductor shortage and ensure a quick return to production. Legislative measures and policy tweaks have been proposed. In South Korea, the government announced a $450 million program throughout 2030, including corporate investment. For China has set up national funds for billions of dollars to invest in domestic chip makers to catch up with companies like the US, South Korea, and Taiwan. Moreover, the United States has approved a technology and manufacturing bill that allocates $52 billion to improve semiconductor design, manufacturing, and research initiatives. Let's have a case study of how United States using $52 billion to allocate resources. In August 2022, President Joe Biden signed the CHIPS and Science, sending more than $50 billion to processor manufacturers over 5 years. As you can see in the pie chart below, 3/4 of the funding will go directly to producers for construction of new fabs and to expand their production. 25% for R&D and workforce, and the remaining of the fund will be used for communications. As a result, the U.S. legislative branch and the semiconductor industry are experiencing a significant shift in the relationship. So let's have a look at the pie chart. You can see Nearly 70% world silicon production and reserve in 2020 in 1,000 metric tons belongs to China. So, the fiscal policy is operated by United States to stimulate the economy and stabilize the price level. Also, the United States want to lessen the reliance on the Asian manufacturer. But the impact of the macro policy is something we need to really consider. It causes lower production in electric devices and more higher unemployment in this industry. So, what is the future of the semiconductor industry? The latest shortage has forever changed the semiconductor industry, even though it has been hit with numerous supply gluts and recessions in the past. Regardless of capacity and component supply constraints, there is no sign of an end to the shortage until at least 2023. But the semiconductor industry continues to progress steadily and reliably to make a meaningful contribution to the economy. A wide range of industries have seen rapid growth as a result of their applications in cars, appliances, and other consumer goods. There have been many different, hugely relevant discoveries made possible by the intervention of the semiconductor industry. Okay, that's the end of my group representation. If you guys have any questions for my group, please leave the comment below and we will try to read all and answer all of them. Have a nice day. Goodbye.